Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I am going to do part 2 of paper solution, that is of Goa Board Chemistry 12th standard, um, of the recent paper of chemistry, that is the year 2024-25. In last part we have seen the questions up to 18 and we have solved each and everything in that video. So today we will solve remaining questions and this includes all the reactions as well. So we will do the completion of part 2 in this video. Okay, so let us start with the solution. Now the next question is, draw the open chain structure of D plus glucose and write the name of vitamin whose deficiency causes bond deformities in children. Now this question is from biomolecules chapter. Okay, so first they have asked the open chain structure of D plus glucose. So how to draw this structure? See, we already know, we have already seen the structures of glucose. So here okay, so open chain meaning to draw in this way, CHO will be on top, that is aldehyde group, then OH and here H. Okay, so OH is hydroxyl group which will be at the right and H is our hydrogen. Then you have to arrange them opposite, so here OH will come and here H will come. Okay, and then you can again write it as it is. Okay, like in the first case, OH hydroxyl on the right, H in the left. Here also same thing, OH and H, and at the end we have primary alcohol, that is CH2OH. Okay, so this is our open chain structure of D plus glucose. Okay, wherein we have OH group here in the right hand side and CHO and CH2OH at the bottom. So this is open chain structure. Now next question under that is, write the name of vitamin whose deficiency causes bond deformities in children. Now this is from the part in which all the deficiencies are given in our textbook when the vitamins in our body they are deficient. Okay, so vitamin whose deficiency causes bond deformities is vitamin D. So answer here is vitamin D. So you can tell this directly. Then now next question is from amines chapter. Among the following isomeric amines, select the one which shows the highest boiling point. Now for this question we need to know the order of the boiling point, meaning the concept, okay, behind the boiling point order. So the concept tells us that straight chain amines, okay, or we can say straight chain or primary amines. Primary amines means, how to remember, the amines in which there is NH2 group. Okay, now there are three types of amines, right? So primary, secondary, tertiary. So amines in which there is NH2 group, they are primary; in which there are NH group, they are secondary; and N group, they are tertiary. So the concept says that primary amines are having more boiling point, then secondary, then tertiary. Okay, so this is the concept. Now you have to apply the concept on this question, that is you have to apply the concept on these three compounds. So first compound is N. Okay, N is present, so we can say that this compound is tertiary amine. Second one is primary and third one is secondary. Okay, so the question is, among the following select the one which shows highest boiling point. So according to concept, primary amine shows highest boiling point, and among these three, primary amine is this one. Okay, so that's why CH3, CH2, CH2, NH2 is having the highest boiling point. And name of this amine, now name is not asked, but in case if it is asked, then name of this amine is what? Since there are 3 carbon atoms, it is propane, and this is amine, so the name is propanamine. So this is the answer. Now if they ask order, then you have to arrange them in the order, but here they have not asked, they have just asked who is showing the highest boiling point. That's why we are giving this as a answer. Okay, so if it is increasing order, then you have to use this signs. Okay, and the one who is having highest will come at the last, and the one who is having lowest boiling point will come first. And if there is decreasing order, then order you have to show by this signs. Next question from the same chapter. Name a reagent which can be used to distinguish between following pair of compounds. Okay, now here there is NH. So NH means secondary amine, and here there is N. So N means primary amine. So there is one test or reaction which can be used to distinguish between secondary and tertiary amines, and that is called as Hinsberg reagent. Hinsberg reagent. Okay, so this is a reagent that is used in that particular reaction, and that will be used to distinguish between secondary and tertiary amine. One of the most important reaction from that chapter. Now next question is, an aromatic compound A with molecular formula C7H7ON undergoes a series of reactions as shown below. Write the structures of A, B, C and D in the following sequence of reactions. So here we are given one formula of a compound, and that compound undergoes this reaction in presence of bromine and aqueous KOH to give compound B. Then that compound B will give in the presence of sodium nitrate and HCl will give compound C. So this reactions takes place. So we have to first now find what is this compound A. Okay, so how you have to go about this problem? We have to see each and every step here. Okay, so you have to also refer to the last step, meaning what will be the product here. Since they have given orange dye, you have to recollect which compound is called as which gives orange dye or is called as orange dye in that amines chapter. So there are basically two compounds in amines chapter at last, in which we carry the reactions. So there we get two types of compounds, that is orange dye and yellow dye. Orange dye is obtained whenever we carry out the reaction and we obtain the para hydroxyazobenzene. So here by looking at the orange dye, we come to know that here we will get para hydroxydiazobenzene. So the structure looks like this. I will draw it here. Okay, so this is para hydroxydiazobenzene, which is also called as a orange dye. Okay, so this is our last product. Now this I came to know because there is orange dye written over there. Okay, but it's not necessary that you should know the structure by looking at that. Okay, because every time it's not hint will be not given this way. So that's why whichever you can detect, that you can write. Okay, now we get orange dye when we react this phenol. Okay, but this compound we should know before that. Okay, so that's why first we will try to see which compound will be this C7H7ON. So here when this compound is treated with Br2 and aqueous KOH, we get compound B, which is further treated with this compound. Okay, now if you carefully observe this compound, okay, what is there in this compound? There is one OH group and there is this benzene with N and N, right? And this benzene with OH group we have added over here. Just look here, benzene with OH, C6H5OH means benzene with OH that we have added, and the additional thing in orange dye which is present is what is this NN. So how you will get this NN? By adding what compound? So we add particularly this benzene Okay, to that we are attaching this N2Cl. Okay, now this is called as okay, so this is the intermediate that we get when we carry out the Saint-Meuse reaction. So Saint-Meuse reaction, in this we get this, and this in detail we have seen in amines chapter. So we can see that in to benzene N2Cl is attached, and that is called as the azo, meaning this N, one N is called as azo, so this is diazo. So this particular compound is called as a benzene diazonium chloride. Okay, so benzene diazonium chloride, when you add to this, okay, C6H5OH, we get this orange dye. So here we have C6H5OH, and so here the compound which is used will be benzene diazonium chloride, so which is called as this, and plus and minus charge over here. Okay, so by using this compound and reacting it with phenol, we get this orange dye. Okay, which is also called as para-hydroxydiazobenzene. Okay, now before that, okay, which compound we have taken to convert this to benzene diazonium chloride? Now this reaction was also there in our first organic chapter, that is haloalkanes and haloarenes. In that we were taking benzene, we were taking aniline to react with this particular reagents under 273 to 278 Kelvin temperature to get the benzene diazonium chloride. So here we will take which compound? Now according to this conditions, reaction conditions, that is NaNO2 plus HCl and here 273 to 278 Kelvin temperature. Which compound we have to take here? Aniline. Okay, that is benzene ring with NH2. So this aniline will be treated with this compound to give benzene diazonium chloride. Now if they ask to write the names, okay, now here in this question they have not asked here to write the IUPAC names of the compounds, only structures they have mentioned. So if they ask names, then you have to mention the names after writing each structure. Okay, so here they have not asked, that's why no need to write. Okay, no marks will get cut. If you know, then you can write, if you know the names of those compounds. Okay, so this is our aniline. Now how to get aniline from this Br2 and aqueous KOH? So that also you have to see. Okay, so I will write the arrow over here, Br2, and we have aqueous KOH. So here to get aniline from this particular reagents, we have to take amide. Okay, and not normal amide, that will be benzamide. So we have to take benzene ring with this CO and NH2. Okay, so this amide, when we treat with bromine and aqueous KOH, we get aniline, and then aniline when treated with NaNO2 HCl, we get benzene diazonium chloride, and further treating it with phenol, we get orange dye, which is called as the para-hydroxydiazobenzene. Okay, now the way I have solved this question, no need to solve in the same way. Okay, it depends on how much you understand. Okay, by looking at the reagents and on some products. Okay, whatever are given, whatever product is given, you have to just see and you have to link them with each other, and then you have to get the product. Okay, because organic chemistry is you have to study all the reactions and you have to link reactions with each other. Okay, only then you will be able to solve the questions like this. Okay, so we are done with this question now. This is the amide, benzamide. When treated with bromine and aqueous KOH, we get aniline. When that further treated with NaNO2 HCl, we get N2Cl attached to the benzene, which is called as a benzene diazonium chloride. And when it is further treated with phenol, we get orange dye or para-hydroxydiazobenzene. Okay, so this is our reaction. So next question is 22nd, that is what is lanthanoid contraction. Okay, now this is one of the most frequently asked question in the past year papers from D and F block elements. So lanthanoid contraction. Lanthanoid contraction related to actinoid and lanthanoids, that chapter F block elements. So we have seen that due to D and F orbitals, there is a contraction taking place in the elements which are there in those blocks. Now why this happens? Because D and F block, they provide poor shielding, they provide very poor shielding. So in simple words we can write the definition of this as gradual decrease in atomic radii from lanthanum to lutetium due to poor shielding of f orbitals is called as lanthanoid contraction. So this is a simple and you can easily understand it, the meaning of the definition. So the gradual decrease in the atomic or ionic radii from lanthanum to lutetium due to poor shielding of f orbital is called as lanthanoid contraction. Okay, so this is the answer. Next question is, write the general formula of the oxide formed when lanthanoid burns in the oxygen. Now lanthanoid, we will take general lanthanoid, that is Ln. Okay, when it burns in oxygen, okay, that means here we will write burns in O2. So when lanthanoid burns in oxygen, we get its oxide, so we get Ln2O3 as the compound. Okay, so lanthanum oxide as the compound. So this is a reaction. Now in this there is a option. Okay, so we will see that next question also under this. So first they have asked, write the electronic configuration of GD. GD is gadolinium, and write the general formula of the sulfide formed when lanthanoid is heated with sulfur. Okay, so first we will write the electronic configuration of gadolinium. Its atomic number is also given. So okay, so gadolinium, we have first we have to write its noble gas, and then you have to go with the configuration. So here we have 64, so its configuration will be 4F7 5D1 6S2. Okay, now this is from F block parts, and they mostly ask only the configuration from that part. So we have to know only few elements configuration. For example, gadolinium, europium, niobium. Now these were frequently asked, that's why I said these names of these elements. Okay, so gadolinium configuration 4F7 5D1 6S2. Next question is under that, general formula of the sulfide formed when lanthanoid is heated with sulfur. So lanthanoid, when heated with sulfur, we get which compound? We get the same as oxide, that is Ln2S3, meaning it is lanthanum sulfide. Ln2S3 is the formula of the compound that we get after combining. Okay, now next is a reaction part. Name reaction 1 and reaction 2 and identify the major product formed in this reaction. Now these are the two reactions which are given, and you have to name both the reactions and also write the major products formed in them. So here we are having CH3CH2Br, that is ethyl bromide. Now by looking at this, we come to know that the reaction is from haloalkanes and haloarenes chapter. Okay, so in that we have first reaction in which AgF is used, and second reaction in which sodium iodide and diacetone is used. By looking at this, we come to know that AgF, now this is particularly we use for Schwarz reaction. So name of first reaction is what? It is Schwarz reaction. And sodium iodide and diacetone we particularly use for Finkelstein's reaction. Okay, so we have these two name reactions. We got the names, and they are same type of reaction which comes under halogen exchange. Okay, both comes under halogen exchange reaction. So here what happens is they are both are simple reactions actually. So whatever halogen you have in the reagent, that will get replaced by this halogen. Okay, so what product we get? We get CH3 CH2F. So only what happens, bromine will come here, fluorine will take this place, and we get CH3 CH2F. So from ethyl bromide we get ethyl fluoride. Same way in second, CH3 CH2Br we have, and we are treating it with sodium iodide diacetone. So when we treat it with this particular compound, we get this I, that is iodine, is getting replaced by bromine. So we get CH3 CH2I, that is ethyl iodide. Okay, and yeah, only you have to mention the names and write the products formed in the reaction. So you have to write the names of the product here. Okay, now in next question, you have to identify the reagents as well here. So identify the reagents 1 and 3 in the following convergence. Okay, so one reaction is given here, and you have to identify the reagents. So here just see what is given. CH3 CH2 CH2OH. Now this is alcohol. Alcohol is converted to carboxylic acid. Normally we convert alcohol to aldehyde or ketone, yeah, primary and secondary. But here it is directly converted to carboxylic acid. And we know that when we use oxidizing agent, we can convert alcohol to ketone or aldehyde. But when we use strong oxidizing agent, we can directly convert the alcohol to carboxylic acid. So here we are using strong oxidizing agent, that is called as KMnO4. So when we use KMnO4, then we can convert the alcohol to aldehyde directly, alcohol to carboxylic acid directly. Okay, so here reagents will be alcohol KMnO4 along with the H2O plus ion. Then that carboxylic acid, when you have to convert it to alpha chloropropanoic acid, you have to take a particular reagent here. So since we are using chlorine here, there is one reaction, okay, Hell-Vollard-Zelinsky reaction, in which we use this Cl2 and red phosphorus. For if you want Cl here, you have to use Cl2. If you want Br here, you have to use Br2 and red phosphorus. So this reaction is given here. Which of the products, propanoic acid or alpha propanoic acid, has more acidic character, and state the reason. Propanoic acid is what? This is propanoic acid and this is alpha propanoic acid. Now they have asked which is having more acidic character, and you have to give the reason. So if you see, the one who is having more acidic character will be this one. Okay, because here there is one proton, okay, this H, there is this proton. Now acid basic definition is what? The acid is the one which can donate proton easily. So this can donate proton easily rather than this compound. Okay, so that's why this will have, and this will have the more acidic character. Okay, now next question is 25th, that is compound X reacts with magnesium in the presence of dry ether to form a Grignard reagent, which is then treated with compound Y containing 3 carbon atoms to form an adduct, which on hydrolysis gives 2-methyl butane 2-ol. Write the chemical reaction involved and name the compounds X and Y. Now compound X, okay, it reacts with magnesium in the presence of dry ether. This which reaction is this? This is Grignard reagent reaction, okay, in which we produce the Grignard reagent. then that Grignard reagent is treated with compound Y. It contains 3 carbon atoms to form an adduct which on hydrolysis give alcohol 2-methyl butane 2-ol. So first of all we will write the final product. Okay, so what is our final product? 2-methyl butane 2-ol. So butane means 4 carbons, 2-methyl, so CH3, and ol, so here OH. So CH3, then C, then CH2 and CH3. Okay, this is 2-methyl butane 2-ol. Okay, so that we get after. No, so before that we have to see what we have to add here. So compound H reacts with magnesium in the presence of dry ether to form Grignard reagent, which is treated with compound Y containing 3 carbon atoms to form adduct. Okay, so compound Y will form an adduct, that we have to write here. So here there is compound Y and here there is compound X. Okay. So X with magnesium in the presence of dry ether. Now here we got alcohol. Okay, so let us take here CH3 CH2 Br. Okay, this as a compound X, and with whom they have treated magnesium in presence of dry ether. So Mg plus dry ether, Mg will get attached to this, so we will get CH3 CH2 Mg Br. Okay, we will get this as a product. So Grignard reagent is formed. Now it is treated with compound Y containing 3 carbon atoms. Okay, so it is treated with one compound containing 3 carbon atoms to form the adduct, and adduct is then converted to alcohol. So we have to see now, these are the reactions. There are 3 reactions actually. One in which you have to treat it with aldehyde, second you have to treat it with okay, one is with formaldehyde, then with any aldehyde, and last is with ketone. So we get tertiary alcohol basically when we treat it with ketone. So that's why how the adduct will form. Adduct should be formed in which you should have 3 ketones. Okay, so this is ketone with 3 carbons. So this should be treated with a ketone having 3 carbons. So CH3 C double bond O CH3. This is a ketone with 3 carbons, and that should be treated with this. Now total here how many carbons we have? 1 2 3 4 5, and here also we have 1 2, and here we have 3 carbons. So there are total 5 carbons. So when this reaction is carried out, what adduct we get is CH3 C CH2 CH3 and here CH3. So all the 5 carbons and OMG Br. So here we get this adduct, meaning after adding these two we get addition product. Okay, that is also called as adduct. So this adduct we got, and this adduct when is further treated or on hydrolysis, it gives us last product, that is 2-methyl butane 2-ol. So you just have to write here chemical reactions. Okay, okay, next question is from D block elements chapter, that is preparation of potassium dichromate from sodium dichromate. So that reaction also I will write here. Potassium dichromate. Potassium dichromate is what? K2Cr2O7. So K2Cr2O7 you have to prepare from sodium dichromate. So sodium dichromate is Na2Cr2O7. Okay, now only you have to replace this with K, right? So for that what we need KCl for that. Okay, so when you write KCl, then K will be, N will be replaced, Na will be replaced by K. So here we will left with NaCl. Here there are 2 Na and here also there are 2 K. So that's why we have to write 2 2 on both the sides, and that's how we get the product or this reaction. Okay. Then next is write any two reasons for catalytic properties of transition metals. This comes under theory from D block. Catalytic, why they adopt catalytic properties, okay, or why they have catalytic nature. So there are basically two reasons. First is they have a tendency to adopt multiple oxidation states. These transition elements, they have ability to adopt multiple oxidation state. And secondly, they can form complexes, okay, they have tendency to form complexes. So these are the reasons for their catalytic properties. Next is why zinc 2 plus salts are colorless while copper 2 plus salts are colored. Now this is based on their configuration. So if you look for zinc, zinc is having number 30. Zinc 2 plus means what? Zinc 2 plus means 2 electrons we have to lose. So configuration of zinc normally is argon 3d10 4s2. When you remove 2 electrons, it will be Zn2 plus, which is equal to 3d10, and 3d10 means d orbitals is fully filled. And if you talk about copper 2 plus, then Cu2 plus, copper 2 plus, copper is having 29 number, and copper 2 plus, so the configuration here is 3d10 4s2, 4s1, sorry, okay. Since this is an exception, you have to have, you can write this as a configuration. So 2 plus means you have to remove 2 electrons. So 1 electron will be from s orbital, 1 will be from d orbital. So we will have 3d9 for s0 or 3d9. So for this you should first know the concept of colored and colorless compounds. So the compounds which are having unpaired electrons, okay, presence of unpaired electrons, those compounds only will show colors, and the compounds which are not having any unpaired electrons, okay, so those will be showing, those will be colorless. So if you observe these two, then in zinc 2 plus we have all the electrons paired, so that means it is colorless, and copper 2 plus is having one electron unpaired, that means it is colored. So that's why we are having zinc 2 plus colorless and copper 2 plus colored. Okay, the next question is write the structures of geometrical isomers of this compound, complex compound. Okay, so we will write the geometrical isomer. Geometrical isomers means cis and trans. So FeNH3 2CN4. So first I will write the formula here, FeNH3 2CN4 minus. Now to write the to draw the structures, no need to find the oxidation state and all. So directly we can draw the structure. Geometrical means cis and trans, and as we know there are 4 CN. 4 CN means if you, okay, so this is our central metal atom Fe, and we have 4 CN. So first we will try to arrange them in this manner, 4 CN, okay, and then NH3. NH3, one will come on top and one will be bottom, okay, and then our charge is -1 or just minus. You can write the charge in this way also, okay. Now next, now this arrangement is what? The arrangement in which all the elements or the ligands which are placed are exactly opposite to each other. It is called as a trans arrangement. So this is a trans compound, and then when you keep them adjacent, like if you have NH3 this way and one NH3 like this, and rest all CN. So CN we have to place on all the remaining places. So CN, 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 and here also CN, and here minus charge. So this is called as a cis arrangement. This is a simple geometrical isomers of this particular compound. The next question under that is, using valence bond theory, you have to deduce the hybridization of inner orbital complex FeCN6 3 minus and comment on its magnetic property. So FeCN6 3 minus. Okay, you have to work, deduce the hybridization and comment on its magnetic property. This compound is having overall charge -3. That means it is an anionic complex. And first, what is the first step that we follow here is we have to find the central metal atom's oxidation number. For that, we should know the oxidation number of this. So we know that Cn is having -1 oxidation number. So let us find this. X plus Cn is -1. How many Cn we have? 6. So x plus -1 into 6 is overall oxidation state is -3. So x minus 6 is equal to -3. So x is equal to -3 plus 6, which is +3. So we have on iron, we have oxidation Fe, we have oxidation number +3. Okay, so we got this as a oxidation number. Now you have to write the configuration for this. Okay, Fe plus 3. So first we will see what is the number of Fe. So the atomic number is 26 and configuration is 3D. Okay, so configuration is 3d6 4s2. Ar 3d6 4s2. Fe plus 3 means what? You have to lose 3 electrons. So after losing 3 electrons, it will form 3d5. 1, 2, 3. So we will try to assign them in the block. So this is D, 3D block. So 5 electrons means 1, 2, 3, 4, 5. Okay, next is 4s and next to that is 4p. Now these are empty. Okay, now see how many ligands are there in this compound. So there are 6 ligands, and which ligands we have? Cn. Okay, cyanide. So 6 ligands means now we should have 6 empty orbitals to take those 6 ligands, paired ligands. Okay, so that we can form the bond, coordinate bond. So first we have to know that whether Cn is weak field ligand or strong field ligand. Okay, that is according to the theory. Now Cn is a strong field ligand. Okay, strong field ligand, and in strong field ligand, why we should know strong field ligand or weak field ligand? Because from based on that we come to know whether it will whether the ligand will cause pairing or not. Now strong field ligand means it will cause pairing, so pairing will take place, and weak field ligand means it will not cause the pairing. So strong field ligand, we have to start the pairing of the electrons. Here we have 5 electrons, right? So that's why in next step we can draw the orbitals again, and we have to see which 6 orbitals are we can make ready to take the 6 pairs of Cn electrons. So here we can do the pairing 1. Okay, so this electron I will take in the first orbital. So one pair we have made, second pair this electrons have taken, and third electron will remain as it is. So empty orbitals, how many we are getting? 1, 2, 3, 4, 5, 6. So we needed 6 orbitals and we are getting 6 orbitals. So yeah, so these orbitals we got. Now we have to see which orbital is getting formed here. So we are using 2 d orbitals and 1 s orbital and 3 p orbitals. That means we are getting d2 sp3 orbital. The new hybrid orbital which is formed is d2 sp3. Now final orbital diagram we have to draw, in which we will assign the pairs in the hybrid orbital. So here we have only 3 orbitals, and then so 1, 2, 3, this is 3d, and this is d2 sp3 orbital, in which we have 6 orbitals, 1, 2, 3, 4, 5, 6. So in this they will remain the same electrons, and the incoming 6 pairs of electrons from Cn will go in this. Okay, and this is how they will form the coordinate bond. Now you have to tell whether they are paramagnetic or diamagnetic, because they ask the magnetic character. You have to look here whether they are getting paired or whether there is unpaired electron in this. So since there is one unpaired electron here, they are paramagnetic. Okay, so like the concept of color, colorless, same is the concept of magnetism. Okay, so you can remember whenever there is unpaired electron, okay, then it means there is colored, meaning colored compound it is, and it is a paramagnetic in terms of magnetic character. So paramagnetic. But whenever it is paired, okay, then it is colorless and diamagnetic. So here you can see there is one unpaired electron, so the magnetic character, it is paramagnetic. Okay, so yeah, this is about this question. Now next is 28th question, which is from electrochemistry. Why copper spoon cannot be used to stir 1 molar silver nitrate solution? Okay, now this is a simple question, theory based question. Why copper spoon cannot be used to stir 1 molar silver nitrate solution? So we know, based on the reactivity series or based on their electrode potential, they are arranged in a particular manner. So based on that, we have to see which metal can replace the other metal. Okay, so according to that concept, copper is more reactive. That copper is having less E naught value, electrode potential value. So copper is more reactive than silver, so it is having less E naught value, and copper will replace silver from silver nitrate solution. So if you use copper spoon to stir this solution, then it will replace silver from this solution, and there is no use of doing that, meaning we are taking to stir that solution, but if that silver only is getting displaced from the solution, then there is no use of stirring the solution. So that's why we are not using copper in that. Okay, rather we will use the elements, meaning the spoon or the other thing which is having low reactivity than silver. So that's why we are not using copper. Now next is the problem in which they have asked the EMF calculation. So here they have given E naught values for copper and silver. So E naught value of copper and silver, and EMF of the cell you have to find. Okay, so this is a reaction. This is a reaction. Chromium plus iron gives chromium ion and iron in the solid state. EMF, what is the formula that we have learned? EMF, which is called as E of cell. E of cell is equal to E naught of cell minus 0.059 by N log of oxidation product upon reduction product. Okay, so here if you observe, who is undergoing oxidation and who is undergoing reduction. So here we have chromium. Chromium lost its 2 electrons and iron have gained the 2 electrons. The one who has lost the electrons is undergoing oxidation. So Cr plus 3 is the oxidation product. So we will write it over here, Cr plus 3, and its concentration we have to write. Okay, so Cr plus 3, and here the other ion, so Fe plus 2. So I will write Fe plus 2. Okay, so we for E of cell, if you want to calculate, then first we need to know the E naught of cell. And how to calculate E naught of cell? E of cathode minus E of anode. And in this reaction, which is cathode and which is anode, that we have to see. So E of cathode, E naught of cathode minus E naught of anode. So the simple way to remember cathode and anode is the value which is largest among this is the cathode. So if you compare minus 0.74 and minus 0.44, then this is the largest value, so that you have to take as a cathode, 0.44 and minus 0.74. So this will give you 0.44 plus 0.4. So the answer will be here 0.30. Okay, so this is in positive, so plus 0.30. So we got E naught of cell as 0.30. 0.30 minus 0.059 by n. Now what is this n? N is the number of ions which are being exchanged over here. Now you can see here Fe plus 2, so 2 ions, and here Cr plus 3, so 3 ions, but we are taking 3 Fe plus 2, so 3 into 2 will be, meaning 2 ions are being exchanged by 1 ion, that is 1 ion metal. So 3 ions will displace how much? They will exchange 3 into 2, that is 6, and here also 3 into 2, which is 6. So that's why n value will be 6, and then you have to write the concentrations over here. Okay, now since they are having coefficient 2 and 3, you have to write them accordingly. So here we have 3 Fe plus 2 and 2 Cr plus 3. So Cr plus 3 raised to 2 and Fe plus 2 raised to 3, and their concentrations we have to also mention. So Fe plus 2 is having 0.1 molar and Cr plus 3 is having 0.01 molar. So 0.01 raised to 2 and 0.1 raised to 3. So 0.30 minus 0.059 by 6 log of 0.01 raised to 2. So 0.01 we can write as this 10 raised to minus 2, and this we can write as 10 raised to minus 1. Now this is raised to 3, this is raised to 2. So 0.30. What is the answer of this? That we have to find first. That comes up to 0.0098 log of 10 raised to minus 4 by 10 raised to minus 3. When you take this up, it will be 0.30 minus 0.0098 log of 10 raised to minus 1. Okay, now mostly students do mistakes here, meaning they first subtract this and then that answer whatever they get they multiply with this log, but that is not right. Okay, that is a completely wrong method that we all are doing. So what you have to do first, you have to multiply the number which you get here with this number after getting the final number, and then after multiplying this, whatever answer you get, that you have to subtract from this number. Okay, and then you whatever you get, that will be your final answer. So 0.30 minus 0.0098 log of 10 raised to minus 1, which will give minus 1 as the answer, because minus 1 log 10. Log 10 is 1, so minus 1 will be answer. And then we will have, so 0.30, this minus will be plus 0.0098. So this will, we will get the answer as 0.3098 and unit will be volts. Okay, so this is our answer of this question, that is E of cell. So we have solved up till 28th question. Now we are left with 29, 30. Okay, mostly organic part we are left with. So yeah, so I will stop here and I will do the remaining questions in the part 3 of this video. Okay, so yeah, that is organic part we will do. Okay, thank you.